Hello, Dr. Fiegel. This week for our class, we studied salinization in soils. We did a week-long experiment where we tracked the germination of bean seeds that were provided in our lab kit. So I guess first off, what is salinization? So salinization, as we learned in this class, is the accumulation of salinity in soil that eventually reaches toxic levels for plants. Now, these salinized soils are detrimental to plant growth and agriculture since most fields, including corn and wheat, are intolerant to even the slightest accumulation of salt in the soils. So approximately 20% of the world's cultivated land is affected by salinized soil, and it's a growing concern. According to our readings this week, by the year 2050, 50% of the world's cultivated land could be contaminated with salinization if nothing is done. But how does this happen? So salt happens naturally in the environment, and the mineral halite is found in rocks such as dolomite, limestone, and shale. Coastal flooding is another environmental cause of salinization. As the rocks deteriorate, the salt contaminates the soil. Salinization is also caused by humans. It's man-made, and the main cause is irrigation of fields. Most irrigation water has some traces of salt, and what happens is when the fields are irrigated and the water evaporates or is absorbed by the plants, the salt stays behind. So when this salt is left behind, it just accumulates. I mean, the traces of salt are minimal, but eventually, as they're left behind and accumulates, it reaches a point where the plants can no longer tolerate the amount of salt that's in the soil. Other man-made causes of salinization include fertilization, road salting, the runoff after roads are salted into fields or into I don't know, the drainage systems that can filter into well water, and land clearing and stream damming. The main problem that salinization causes prevents roots from absorbing water, as we have seen in the lab this week. This also affects germination in seeds. When salt is absorbed, even very low concentrations of salt can cause a reduction in leaf growth in plants, so stunting growth. And finally, most plants cannot excrete salt, so causing a chemical imbalance in the cells that eventually leads to the death of the plant. So what we're going to do now is I'm going to show you kind of a clip of me setting up the lab this week and the 24-hour follow-ups to it. And I had some pretty good help. My 3-year-old son, Sebastian, and I think you see my newborn daughter in the video. Also, thank you very much for the extension. A lot's been going on here in the household, so definitely appreciate you working with me with the extension for this project. All right, so here we are setting up our project, making the salt solution. We've got some pretty good tunes in the back, trying to have fun, so enjoy. All right, and here we are finishing up our project setup. We've made the saline solution, the salt solution, and added to the appropriate Petri dish. And just about now, you can hear my wife kind of killing our fun and telling Alexa to be quiet. So we'll see you shortly. Good evening, Dr. Fiegel. So it's been 24 hours since we placed our beans in the Petri dishes. The most notable difference is 0.0%, so just pure distilled water. We could definitely see the condensation on the top here, the buildup of condensation. The rest of them
have no condensation, so not sure why that is. I mean, I have an idea, but I can't be for certain. In the interest of time, I have gone ahead and I've already weighed the Petri dishes after the 24 hours. It looks like they've all lost a little bit of mass. So now we're just gonna fill them up and give it another 24 hours and check in. Hello, Dr. Fiegel, and welcome to day 5, the fifth and final day of our experiment. Looking at our Petri dishes here, we can see our purely distilled water has now grown roots, which is pretty cool. Moving on down the line to the 0.5% saline solution, we see no action. The beans look like they may have absorbed some water, but I don't see any germination happening. And the same happens as we continue on to the 2% saline solution here. The only difference in the 2% is that now we have well, actually a lot more crystal formations from the salt. But yeah, this kind of wraps up our experiment, and I'll move upstairs for a final discussion.
All right, Dr. Fiegel, if you watched that entire video, I appreciate you bearing through it. This is my first time ever making a video and trying to compile different clips. I thought I did okay. Definitely room for improvement. So let's wrap up really quick, maybe with a discussion about our observations of the experiment and answer some of the questions that were in this week's lab. I did bring 2 Petri dishes up to the office, just kind of to show as an example. So the purely distilled Petri dish with our beans, I know we saw them earlier, but these have grown roots. So one of the questions was, what was the purpose of using distilled water? And the only thing, my answer is distilled water is water that has been boiled into vapor and condensed, so it's kind of like it did here, and then condensed back into a separate container. So all the impurities and salts and other stuff that's in the original water do not transfer over to the new container through the water vapor. So that's the reason why we use the distilled water. Basically, bottom line up front is because it's pure water. All right. Why were the Petri dishes containing the beans weighed at 24-hour intervals? And this was so we can observe the water absorption and just to make sure our beans do not dry out. We also kind of know I on the side I noted the differences between weigh-ins every 24 hours, and it looks like on average we were probably losing about 0.25 grams of weight. I'm going to say water weight per weigh-in. So the beans, there were 3 classifications given to us for germination classifications, and these were complete, incomplete, or none. So the minimum salt concentration that affected bean germination was any salt at all. So 0.5% solution had a direct and clearly evident effect on the germination of the bean species. I think the 0.5, I would maybe categorize it as incomplete, but going up, it was just zero germination. So 2 other things we learned in the class were, and I don't know if I'm pronouncing these right, halophytes and glycophytes. 2 different plant species or maybe categories. So 1, halophytes are salt-tolerant plants with adaptations to grow and reproduce in salinated soils. But I guess this kind of answers the question: when you go to the beach and we see plants and even trees, palm trees growing, how does this happen? Well, these plants are halophytes, as I have learned this week. And some of these plants include like the saltbush, the saltgrass, pickleweed, seaweed we see underwater. They wrap around your leg and freak me out every time I'm swimming in the ocean. And palm trees that we see along the beach or sometimes on desert islands. But many of these plants have salt accumulators, so this is a form that they've adapted to the growing conditions. And they absorb salt throughout the growing season and store excess salts in glands. And once these glands fill up, they eventually burst, releasing all of the salt back into the environment. Or they also, some of the halophyte plants have what are called salt excluders that lose leaves when the concentration approaches toxic levels in the cells where the salt accumulates. Other plants have adaptations to exclude salt from entering the epidermis of the roots. So that's one of the things that we discussed earlier, was one of the main problems with salinated agriculture fields is that it prevents roots from absorbing the salt. And this would be glycophytes, right? So glycophytes, which are the majority of plants on Earth, are non-salt tolerant and damaged by almost any traces of salt. So anything over 1% salinity. In our lab this week, our beans are definitely glycophytes, as we can see. So this concludes my video. This concludes my lab for this week. Again, thank you for working with me on the extension, and I hope it comes out okay. See you soon.